All right, so in 1.2, we're going to look at frequency distributions.
I like frequency distributions.
Yeah, it's a good way to summarize data.
Yes.
Yeah. So this data set here is the ages of students in an evening section of statistics at Pellissippi. Now, notice the frequency distribution is created by counting how many data values fall into each class. So the class are those equal-sized groups.
Sometimes they're called bins. Mm-hmm. Yes.
Yeah. And
by equal size, you don't mean they have the same number of people in them. You mean it's the same, like...
interval.
Same interval width.
Mm-hmm.
Yes.
Yeah,
okay.
Yeah, the same interval width. Yeah. So if this is just my list here of data for the ages of the students.
For those of you who cannot see, she's pointing at it.
Oh. This is my list of data. And what I want to do is summarize that into my table.
Yes.
And
so that it's easier to see what's going on. It's really hard to see from looking at that data exactly what's happening.
Yeah, and imagine if I had a data set that was like 3 times that size.
Oh, yeah.
You know,
yeah.
I wouldn't want to just look at the list of numbers. I would want to summarize it.
Right.
And that's what descriptive statistics is all about, is summarizing and presenting information in a more digestible way. So, so we can see here, you know, in the age group, 16 to 25, the frequency is 3.
So if we count it up, there'd be 3 of them.
Yeah, and so that's referring to that group right there, right?
Yep.
Yeah. And then in the next class, or the next bin, I have the age group 26 to 35, and that's 7. And the next group, so on and so forth. So what we're going to show you is, you know, if I have this frequency distribution here, I can also make what's called a relative frequency.
And that's more like, it kind of reminds me of a pie chart.
Mm-hmm.
It tells you like what percentage
Yeah.
of the whole class is in each of those groups. What percentage of the class of students is in each of those groups.
Yeah. And then the next one is a cumulative frequency, and that's like thinking, you know, that much or less, right?
Yes.
So in the first group, you know, it's like how many students are 25 or less, right?
Right.
In the second group, how many students are 35 or less?
Oh, I see what you're doing. You're using the last number, the highest number in the class in the class that you got there, like 26 to 35.
Yeah.
Okay.
Yep. So for the relative frequency, it's a fraction. I need to know what the total is down here. So how many total students do I have?
It looks like 22, but no, 32.
Yeah, 10, 22, yeah, 32. So the sum there is 32. And so to get this relative frequency, I'm going to take the frequency 3 and divide that by 32.
Okay.
And what do I get?
3 divided by 32?
Mm-hmm.
I get 0.09. How far do you want to go?
We'll just do 2 decimal places.
0.09.
Okay. So, because it's 0.09375. So we'll just kind of round these. And, so 7 divided by 32.
0.22.
0.22 or 22%.
Yes.
Okay to write that as a percent.
12 divided by 32 is 0.38.
Okay. Oh, I can do 8 divided by 32.
Oh, can you?
I can. That's
good.
0.25.
Good. And then 2 divided by 32. Oops, I'm behind you.
Oh, that's okay.
0.06.
Right. Good. So instead of just telling me the number of data values that fall in that class, the relative frequency can show me what proportion or what percent falls in that class.
Right.
So I can see that, 38% of the students are between 36 and 45.
Right.
Yeah.
Okay.
And
that actually adds up to 1.
Oh, it adds up to 1.
Usually with round off error, it adds up to like 0.99 or 1.001, but this one adds up to 1.
Yeah, because I want it to account for 100% of my data, right?
Yes.
Good. So for cumulative frequency, I have 3 students who are 25 or less. And then I just add the next frequency.
Right.
Right? So 3 plus 7 is 10.
So there's 10 students that are in the class that we're sitting in, which is this 26 to 35, or less than that, which would be the ones above it. Okay?
Yep. And then if I add 12, then I would get 22. And if I add 8, I would get 30.
Yep.
And then
you
32.
expect the last one to be the same as your total.
Yep, exactly.
Yep.
Yep.
That's it. Is that it?
Well, we have a couple more questions about this frequency table.
That's right.
So,
and we need to define class. And here's why this has been confusing for me. I've been being careful to say class, because we're talking about a class of students.
Oh, right.
Which is a classroom full of students.
Yeah.
But these sections are also called classes.
Yeah.
So I've been faltering as I've been saying the word class, trying to figure out how to say it so that it was clear.
Yeah. So I would call this the first class.
Yes.
Right? 16 to 25.
And they're always called a class. It's not in reference to this class of students. The frequency table, it's always called a class.
Yeah, yeah. So the class width, okay, the class width, you have to be careful about this because it's not the difference between, this is called the lower class limit and the upper class limit. It's not the difference between those values. It's what my consecutive lower class limits are going up by.
Can we highlight it? Can we use a highlighter and highlight the two we're going to subtract?
Sure, yeah. So 16 and 26, right? What's the difference between those two numbers?
10.
10.
So my class width is 10.
Right. So be careful. It's not the difference between the lower class limit and the upper class limit. It is the difference between consecutive lower class limits.
And when Christina earlier said equal classes, what she was talking about was that all of these have a class width of 10.
Right, yeah. So the difference between 16 and 26 is 10, and then the difference between 26 and 36, 36 to 46, 46 to 56. Yeah. Good. And then the upper class limit, okay, is the highest value that can be in a class.
Okay.
So if I look at the third class, 1, 2, 3, that upper class limit is 45.
Okay.
Okay. And then the midpoint is the upper class limit plus the lower class limit divided by 2. Okay, that's how I find the midpoint. I take the average of those two numbers. So if I look at the fifth class, then that is going to be 56 plus 65 divided by 2.
Which is 121.
121 divided by 2?
Which is 60.5.
60.5. Good. And so we use that midpoint in some of the calculations that we'll do later. So we just want to show you how to find that.
Okay, that's it.
All right.